MCP202x, LIN Transceivers with Voltage Regulator, Microchip. Welcome to this training module on Microchip's MCP202x family of LIN transceivers with voltage regulators. This training module introduces the LIN transceivers, their features, and typical applications. LIN is a single-wire serial communications protocol based on the common SCI byte-word interface. The medium access in a LIN network is controlled by a master node so that no arbitration or collision management in slave nodes is required, thus giving a guarantee of worst-case latency times for signal transmission. A particular feature of LIN is the synchronization mechanism that allows the clock recovery by nodes without quartz or ceramic resonators. The specification of the line driver and receiver is following the ISO 9141 single-wire standard with some enhancements. A node in LIN networks does not make use of any information about the system configuration except for the denomination of the master node. Nodes can be added to the LIN network without requiring hardware or software changes in other slave nodes. The size of a LIN network is typically under 12 nodes. LIN is a serial communication system intended to be used for distributed electronic systems in vehicles. The MCP 2021 and MCP 2022 LIN SAE J2602 transceivers are third-party LIN J2602 approved, OEM approved, and AEC-Q100 certified to meet the stringent requirements of global automotive manufacturers. The transceivers include built-in voltage regulators and are compliant with the LIN Bus 2.0 and 2.1 specs, as well as SAE J2602 standards, and the previous generation of LIN 1.x standards. With their built-in voltage regulator, the MCP202x family transceivers reduce the number of external components needed, which increases system reliability and reduces overall design size. The MCP202x family provides a physical interface between a microcontroller and a LIN half-duplex bus. It is intended for automotive and industrial applications with the serial bus speeds up to 20 kilobaud. The MCP202x transceivers are appropriate for a wide range of applications in the automotive market, including rain sensors, sunroofs, window lift, seat position motors, seat control switches, radios, entertainment systems, GPS navigation, mobile telephone equipment, mirrors, steering wheel control, compasses, and garage door openers. The devices are also appropriate for applications in the industrial marketplace, large lawnmowers, golf carts, metering and door locks, and medical, motors, control panels on wheelchairs, hospital beds, and appliance markets, washing machines, stove control panels, and sensors. The MCP202x provides a half-duplex bidirectional communications interface between a microcontroller and the serial network bus. This device will translate the CMOS and TTL logic levels to a LIN logic level and vice versa. The MCP2021-500 provides a 5-volt or 3.3-volt 50 milliamp regulated power output. The regulator uses an LDO design, is short-circuit protected, and will turn the regulator output off if it falls below a threshold voltage. The MCP202x also includes thermal shutdown protection. The wake-up submodule observes the L-bus in order to detect bus activity. Upon application of battery supply, the device enters the power-on reset mode. During this mode, the part maintains the digital section in a reset mode and waits until the voltage on pin VBB rises above the on threshold to enter the ready mode. If during the operation the voltage on the pin VBB falls below the off threshold, the part comes back to the power on reset mode. Upon entering the ready mode, the voltage regulator and receiver threshold detect circuit are powered up. The transmitter remains in power down mode. The device is ready to receive data but not to transmit. In operation mode, all internal modules are operational. In the power down mode, the transmitter and the voltage regulator are both off. This is the lowest power mode. The transmitter off mode is active whenever the fault and TXE signal is low and the L-bus transmitter is off. The transmitter is also turned off whenever the voltage regulator is unstable or recovering from a fault. This prevents unwanted disruption of the bus during times of uncertain operation. The devices, with their world-class electrostatic discharge performance, enable reliable communication even in harsh environments with minimal or no external components required. The LIN bus specification states that the LIN pin must transition to the recessive state when ground is disconnected. Therefore, a loss of ground effectively forces the LIN line to a high impedance level. The thermal protection circuit monitors the die temperature and is able to shut down the LIN transmitter and the voltage regulator. The MCP202x has a low dropout voltage positive regulator capable of supplying 5 volts DC plus or minus 3% at up to 50 milliamp of load current over the entire operating temperature range of negative 40 degrees C to positive 125 degrees C. Designed for automotive applications, the regulator will protect itself from double battery jumps and are up to positive 43 volt load dump transients. The voltage regulator has both short circuit and thermal shutdown protection built in. If the thermal protection circuit detects an over-temperature condition and the signals TXD and RXD are low, or TXD is high, the regulator will shut down. When the input voltage drops below the differential needed to provide stable regulation, the output voltage regulator will track the input down to approximately 3.5 volts, at which point the regulator will turn off. This will allow microcontrollers with internal power-on reset circuits to generate a clean arming of the power-on reset trip point. The MCP202x will then monitor VBB and turn on the regulator when VBB is 6 volts. Here illustrates the typical connections between a microcontroller and the MCP202x transceiver. The microcontroller is driven by the voltage regulator of the LIN transceiver. CG is the load capacitor and should be a ceramic or tantalum rated for extended temperature ranges. CF is the filter capacitor for the external voltage supply. Per the definition of the LIN specification, only one master node is allowed in a LIN network configuration. The communication in an active LIN network is always initiated by the master task. Exactly one slave task is activated upon reception and filtering of the identifier and starts the transmission of the message response. It is possible to communicate signals directly from slave to slave without the need for routing through the master node, or broadcasting messages from the master to all nodes in a network.